Okay, I'd like to sketch the line through the point 14 and 39 and find the slope. So there's the point 14, there's the point 39. There's a line that goes through both of those 2 points. And this is, a good computer drawn picture. If on paper you draw a kind of rougher picture, that's going to be fine. For the slope, let's see, change in y, 9 minus 4, change in x, 3 minus 1. So we're going to get 5 over 2. Okay, we could also have computed this to be 4 minus 9 over 1 minus 3. We just got to make sure that the order, if we swap the 4 and the 9, we have to also swap the 1 and the 3. So this will be negative 5 over negative 2, which also still is 5 over 2. So either way, you get 5 over 2. Okay, we're done with the question, which is what the happy face is about. But I just want to talk about what slope really means. And it's a little strange to talk about the x change first, the change of 2 units in x. So I'm going to talk about the run first and the rise next, but it works this way as well. So for every 2 units moved to the right, so that's a change in x, change of 2, you're going to have to move 5 units up. So for a 2-unit run, you have a 5-unit rise. By the way, if you just take the 2 and the 5 and you divide both by 2, we can say it this way. For every 1 unit change to the right, you have to move 5 halves units up. I like actually talking about 1 unit change to the right, and then talking about how much you move up, because that 5 halves right there is the slope, and this actually puts a lot of information behind the fact that the slope is a rate. So for a 1 unit change to the right, how much do you end up moving in y? You move 5 halves. Okay, let's sketch the line through the point negative 7 comma 9 and the point 1 comma 4 and find the slope. So there are the 2 points. And then we will just, again, computer drawn, it's a much more accurate drawing, but there's a line and we'll find the slope. So change in y, so 4 minus 9, change in x, 1 minus negative 7. So we have negative 5 over 1 plus 7, in other words, negative 5 over 8. And you can write the minus sign in the numerator or just to the side of the fraction, so you get negative and then the fraction 5/8. For a rate type interpretation, for every 8 units moved to the right, you have to move negative 5 units up, or in other words, you have to move 5 units down. And we can also say for every 1 unit moved to the right, you have to move negative 5/8 unit up, or move 5/8 units down. So let's compare the 2 drawings from the previous 2 questions. We had a line that's kind of tilted this way. We have a line that's tilted this way. We had a slope of 5 over 2, positive 5 over 2, and we had a slope of negative 5 over 8. So as you travel along the x-axis, right, if you travel from left to right along the x-axis, like this way and then this way, left to right, if the slope is positive like we had here, then the line rises. Whereas if the slope is negative like we had here, then the line falls. Okay, I'd like to sketch the line through the point 33 comma 5 and the point negative 10 comma 5 and find the slope. So there are those 2 points. Sorry, due to the scaling, the points look so close to the x-axis. But you'll notice that the y-coordinate is 5 for both of these 2 points. And there's the line. If we compute the slope, we're going to get actually 0 over 43, which is going to simplify to 0. Okay, if you swap which point you put in first, you still have 0 over something, 0 over negative 43, and that simplifies to 0. In either case, the slope is 0. And what I want you to notice is a thing that happens in general for horizontal lines. So a completely horizontal line will always have slope 0. Don't say no slope. Say slope is 0. 0 is a number. Sometimes people try to say no slope, and that's going to be incorrect. So remember, the slope is a rate, and this still applies. If the x-coordinate changes by 1, then the y-coordinate changes by the slope value, which is 0 here. Okay, let's sketch the line through the point 3,5 and the point 3,11 and find the slope. So there are the 2 points. You'll notice that both points have the same x-coordinate, namely 3 in this example. There's the line. It's perfectly horizontal. When we try to compute the slope, for example, you can have 6 over 0. You can't divide by 0, so the slope is actually undefined. So it's something that's true in general, not just for this vertical line, but it's going to be true for any vertical line. So a completely vertical line is going to always have no slope. So this is why earlier we didn't want to use the phrase no slope.